for the introduction. Can someone turn my mic on, please? Can someone turn my mic on? There we go. Good afternoon, everyone. Welcome back from lunch. I hope you enjoyed the socializing and networking with your friends and colleagues. I'm very happy to be kicking off the next session, which is on real-world implementations of GA4GH standards. So we had some nice introductions to some global and European projects this morning. So now we really get to dive into the details and get dirty with those GA4GH standards. So I'm very excited for that. First up, we have our keynote. I'll introduce Dr. Nara Sobreira. She's an associate professor at the McCusker-Nathans Department of Genetic Medicine at Johns Hopkins University School of Medicine. Her area of expertise is rare Mendelian phenotypes, analysis of next-gen sequencing, and functional testing of candidate causative variants. She is one of the creators of Gene Matcher, Variant Matcher, and one of the co-founders of the Matchmaker Exchange, and these are all intended to share next-gen sequencing data. She has worked extensively on functional studies that evaluate the possible pathogenic effects of the candidate causative variants. Nara, welcome to the stage.
Thank you. Good afternoon, and first of all, thank you for having me here today. I'll tell you a little bit of the work that I have been doing together with many people in here. So let's see if I can get it all right. The work that we are doing, like in the last 15 years already, is all to share phenotypic and genomic data to improve classification of rare variants and improve the discovery of novel disease-causing genes. And that's a disclosure because I'm going to show some data that we did with a lab in Brazil, and I'm a consultant for this lab called DASA. But this work basically started in 2010 as part of a project funded by NIH that was called Centers for Mendelian Genomics. And the program lasted 100 years and had 4 centers, among them the Baylor Hopkins Center for Mendelian Genomics, the Broad, Yale, and University of Washington. After that, we continued that work as part of other projects. One of them is the Gabriela Miller Kids First project, also an NIH-funded project, also to sequence patients with rare diseases. And as we were doing all these projects and sequencing all these patients with rare diseases, that is a snapshot of what we identified at the Hopkins branch of the lab, of the project. And we identified many novel disease genes that had previously been associated with some kind of disease, but now were associated with novel disease genes, with a novel phenotype. And we also identified many phenotypic expansions. That meaning, like, we found a disease that now we could say that it was a little broader in the phenotypic presentation by knowing that that gene that was already known was mutated in that patient. But we also identified many novel disease genes as candidates. And when we find these candidates, we want to find more evidence that they are actually the causative gene. And one of the ways that we did that was by sharing the data. And that's what I'm going to tell you a little bit of how we have been doing that as a community in the last 15 years. That is our recipe for making these discoveries of novel disease gene association, novel disease gene discovery, or phenotypic expansions, and other things that we have been doing as part of this project. But basically, we would identify the patient. We would have the phenotypic description as detailed as we could. Then we put together the genomic data, and we would share that data to actually find more patients and find the evidence that we needed to the discovery of the novel disease gene. So that is our recipe that we have been using for the last 15 years as part of these projects. But we haven't solved everything. As you see in this graph, there are many more genes to be found. We went from 2010 to 2015, from 2,500 disease genes to 5,000 disease genes in OMIM. But we still have about 15,000 genes that we don't know what they cause when there's a mutation in one of them, a variant, a pathogenic variant in one of them. And we have, at least in OMIM, at least 3,222 phenotypes that we don't know what's the gene that caused that. And that's an underestimation, because not every rare disease is actually cataloged in OMIM. but these ones are, and we know that we don't know the genes for that ones at least. So we have much more work to do, and we do believe that we need to continue sharing the data to actually find the answers for these diseases that we don't know the genes and for the genes that we don't know what they cause. And you see here, let me see if that's the pointer, yes. So what I have been telling you is basically how to share research data, or what I'm going to tell you is basically how we have been sharing research data. But we believe that to actually get to the answers that are missing here, we need to start getting all the partners on data sharing the data. So we need the patient-led data to be shared. We need the hospital data to be shared. We need the clinical laboratory data to be shared. It all needs to be shared in a global network to facilitate the novel gene discovery that we need to achieve. So that is what we have been working next, trying to get as many partners as possible on this network to share phenotypic and genomic data to identify these genes that cause the rare disease that we are studying. Now, as part of our work, we have developed some tools, and I'm going to tell you a little bit about them today. And the tools that we have developed are, PhenoDB, GeneMatch, and Variant Match. I'm going to talk about GeneMatch and Variant Match today, but it started with a database that we created, PhenoDB, to actually store the phenotypic and genomic data that we had created, or we were creating as part of the Centers for Mendelian Genomics project. And once we had this database, we decided we needed to share the data, and we created GeneMatcher first. And we heard a lot about regulations this morning, and GeneMatcher was basically created to get around regulations as much as we could and make it as easy as possible to everybody in the community, not only the researchers, but also the clinicians and even the patients, the healthcare providers, to share the data best possible way that they could. And so GeneMatcher was created for that, and at the same time, we were creating GeneMatcher. That was back in 2010. Another database was being created in Canada. It was Phenome Central. And back in 2010, Heidi said, well, if these two databases are being created, why don't we start talking about how to get these databases to communicate? So the users don't have to go to one database and then to the other database. They can go to one database, and from there, they can query every database that's connected through the network. So with that in mind, we had our first meeting, I think, in 2010 in the ASHG to talk about how to connect this database, and that's when the Matchmaker Exchange was created. The Matchmaker Exchange was created exactly to have an API that would connect any database that was sharing data the same way that GeneMatcher was. And now you see that we have many databases connected through the Matchmaker Exchange, and they are from different places in US and different countries also. We have UK, we have Europe, Patient Matcher, we have Seeker, US, Broad, IRUD, Japan, RD Connect Europe, MyGene2 US, Phenome Central Canada, Monarch, that I think it's based in US also. So we have all these here connected. When you go to one database and you query your gene in one of them, you can also query all of them at the same time. Now, as we were developing this API, that one was one of the first two driver projects from the GA4GH that was also just starting. And Peter was talking about them as one of the driver projects at the very beginning of the GA4GH. So we started with GA4GH, and we were informed by the many work streams that the GA4GH has ongoing now, and we also informed many of them on the needs of what did we need to actually connect these databases and share this data in a way that would benefit the community as much as possible. So after that, we went on to develop the variant matcher. Another way to share the data that we have is stored in PhenoDB. In here, the match is based on a gene name. In here, the match is based on the variant itself. So that is just a way that we have been expanding. In that side, we continue trying to get all the nodes connected to GeneMatcher, so more data can be shared through GeneMatcher, through Matchmaker Exchange. But as I said, we are bringing all the groups of patients, and here it's a patient-led database that is now looking to being connected to GeneMatcher. They already have the database, they're already connected, but now they're looking to how to actually feed that database and get this data shared through this network. And here's another research lab that's also connected through GeneMatcher. So that continues to expand. And here in this side, we start a second project that is a continuation of the Matchmaker Exchange that I think we thought at some point we were going to get called Matchmaker Exchange V2, but right now we have the variant level matching project, and I'm going to show you a little bit about it later. But the same way we have connections through the Matchmaker Exchange, we want to have connections through this variant level matching project. And here you see that as of today, variant match is connected to Franklin by Genox, MyGene2, Gene2MP, and Seeker the Broad. So as that continues, everything that is in red here is the plan for next connections. And you see here that we have, on both sides, gene and variant, we have GA Genomics PhenoDB that is basically a clinical lab at Hopkins that we are planning to connect to both networks. And we have also our Hopkins clinical database that we are also planning on connecting in both nodes, in both networks. And then we have other research labs connecting to the variant level side and all the databases around the world connecting on the variant side to the network of variant level matching project. So everything that is in red here is planned to the future, and we want to continue embracing all the databases and all the communities to improve the data sharing that we were talking about at the beginning. Now, when we talk about data sharing, it's also important to have its own database. Right? And we heard many talks from around the world today, and some of them have databases that are already ready to connect, and they have to figure out if they would be willing or wanting to connect, and also if the regulations that they have in place would allow them to connect and exchange the data the way we are doing. But many places don't have a database. They don't have the infrastructure that is needed to actually share the data. They have the data, but they don't have a way to store that data, not only the genomic, but the phenotypic data in a way that can be exchanged. So one of the things that we have been working is to work with these communities around the world to actually help them to have a database that can be used to connect to the networks and share the data if they can, based on regulations that each one have in the different countries, and also based on the kind of data that they have. Research data is one thing, clinical data is another thing, patient-led databases follow another set of rules. So we have to have that in mind also, but the first step is to actually have the data stored in a structured way that can be connected. So you see here that we have been working with many countries in Brazil, and that's because, of course, I'm from Brazil, so no bias there. But we also have the UAE, we also have some centers in India also working on connecting, not connecting, on having their own database to then next see how they can actually share the data if they can. And you see that we are reaching out also to different types of data. This is a clinical laboratory, like I told you that I was going to tell you, and that's a hospital database. So just to tell you a little bit about the tools that we have, GeneMatcher, I don't know if you have heard, but as I said, it's based to share gene. I found a gene that's a good candidate on the cohort that I'm studying, and I want to find other patients that have mutation or variant in the same gene. I can use GeneMatcher for that. And here is the data of GeneMatcher as of October 1st. We have almost 17,000 genes that were submitted by 23,500 users from 114 countries. Of these 16,000 genes, 12,000 of them have matched. Some of these matches went on to be proved to be actually the cause of the disease that is being investigated. Some of them were proved not to be, and some of them are still under investigation. But many people have been using GeneMatcher beyond the researchers. We have users in GeneMatcher that are also clinicians, healthcare providers in general, patients, and we have clinical laboratories. And here we have this piece from January 2025, where this lab in US, GeneDx, tells us about the use of gene match and how that has helped them to publish more than 85 public papers describing novel disease genes. And here's another clinical lab telling us about their experience in 5 years using GeneMatcher. So we see on the gene side, clinical laboratories already participating, but we would like to see that expanded. Of course, they have also, beyond willing to share, they have the issues of like how to do it, how to actually fund it, and how to continue the process, because not sharing is not the only thing. After you share, you have to actually have time to follow up on the matches, to actually communicate with the other people who shared with you and contacted you, and actually continue the investigation. So that's a whole process that's not simple. We here see that some clinical labs have done it and they think it's worth it. But for the ones that want to do, it's not as simple as just, I want to do it. GeneMatcher has enabled more than 900 publications describing more than 720 novel disease genes, and this is a graph that we put together in a paper from 2022 describing how it was being used and also who was using it. And in this graph, we can see that it's not only the high-income countries that have been using it, but middle and low-income countries have been using it. And that actually is very important for me. Being from Brazil and coming from Brazil and seeing how many times it's hard for us to get into that network. So it really makes it important for me that the tools that we are creating can reach out to everybody, not only the high-income countries. So, of course, our goal is to improve the lives of our patients always, and it has allowed us to have good results in terms of finding the genetic cause and helping with treatment and guidance for the patients that have the disease that we are studying. But the next step was creating Variant Matcher, and Variant Matcher is, as I said, to share variant-level data. We have in our database about 7,000 individuals, the data from 7,000 individuals, and about 1,600 submitters from 64 countries have come to our database to look for variant of interest. So 26,000 variants have been queried, 500, almost 600 of them have matched to 9,260 individuals. And I'm going to, we have only 4 minutes, and that's how you would use it. That's the email notifying about the match. But you can see here that we only have the email notifying the match. You also get the information about MyGene2, Gene2MP, Franklin by Genox, and the Broad here. And to connect these databases to Variant Match and create this first network, we actually had a lot of discussion, and we used the Beacon API. So that was our next step on GA4GH standards. What standard would we use here? For the first one, we created the API, and now we decided that the API was not the most appropriate, and we had the Beacon API, we had the Data Connect API, and we spent a year discussing what would be the most appropriate, and we decided to go with the Beacon API. So now we are connected. These are here, the statistics that we started compiling since September of like who is sending what to whom and what is matching in what database. So you can see that we have the data from Variant Matcher, and then we have against Broad, Franklin, and MyGene2, and the numbers increasing from 1 month to the other, and I hope that that will only increase with time. And I want to say, Franklin by Genox, while that service that they offer here is public, they also have they are actually a profit company, right? So we start going beyond research databases only to that other arena of databases. So I'm going to go fast here, but that is basically, we used the variant of uncertain significance that we identified in this lab called DASA from Brazil to actually see if we use the variants of uncertain significance and share that data through Variant Matcher, what we would find and how that would improve classification. And basically, you see that from 63 variants of uncertain significance that we followed up in Variant Matcher, we were able to reclassify 32% of them to likely benign or benign. And then here's how you reclassified. Most of them were likely benign or benign, and we had one that was actually pathogenic. And now we went on to get a sample of variant of uncertain significance from a project in the UAE to do the same thing, and we saw that of 111 variants that we started with, 20 of them matched the invariant matcher, and by checking the phenotype, we were able to reclassify to likely benign or benign 12 of them. 83 that didn't match invariant matcher, 59 of them still matching Franklin to MP, but now we need to follow up on phenotyping, and that's part of our project. We are trying to see how to give more than numbers and how to give phenotype information to actually enable this reclassification that we got here because we had the phenotype to compare. So by looking at that, we saw that the reclassification was much better when we were talking about diseases that were autosomal dominant caused by heterozygous variants that cause disease that are high penetrance, complete penetrance, and early onset. But we have to be careful with incomplete penetrance, variable expressivity of the phenotype, and age of onset before we say that the variant is benign or likely benign. I have 1 more minute, and that became the federated variant level matching project. That is a GIF from GA4GH using the Beacon V2 API. And we are actually, as part of this project, reaching out to many other work streams to decide what it is that we are going to standardize, how we are going to standardize variants, how we are going to standardize the indels nomenclature, how we are going to do the exchange of phenotype, how we are going to deal with regulations for data that's beyond research. So you can imagine that we actually use products from GA4GH from many work streams to do that project. And I just wanted to, that's one slide before the last that's actually got a little weird here. But I just want to say that this project actually started back in 2018. And we had many generations of people working on that project. That's not everybody, and people here in the room will know that there are many more people working on it. That is just some of the technical people that I have directly worked with in the last almost 10 years. And we started with Harindra, Francois, and Ben, and Kyle. This was at the time Illumina. That was at the time Ben was at Decipher, Francois at Hopkins with us, Harindra at the Broad with Heidi. And then after that came Miro and Jonathan working on the discovery work stream and actually developing the Data Connect API that we thought we would use for that. And then the next generation here, there are people from Hopkins, people from the Franklin team, and that was a discussion that took a year to decide between the Data Connect API, the Beacon API. We came to the Beacon API, and now we have the next generation working on actually using the Beacon API, making the implementations that we need to do what we need as the variant level matching project. Corina, Tudo, and Hannah working with us on this project. So you can see that it takes time. It takes many different groups throughout the time, and it's a continual process that doesn't end, but involves many work streams at Global Alliance and many people like directly or indirectly linked to it. So, of course, I want to thank the people that work directly on this project with me in my lab and the people who collaborate with me around the world and in the US for all these projects that we are working on. Thank you so much, and I was right on time, I guess.
You are perfectly on time. Great job. Okay, great. So now we'll move into the Q&A portion. So as a reminder, go to Slido. You can put in GA4GH, add your question, and also upvote questions. So we'll kick off with, I think it's the first rated. So since Hopkins is using PhenoDB to assist others to stand up data sets to share their data in the variant matcher network, does this mean that PhenoDB will adopt GA4GH standards for representing these data?
Yeah, that's a great question. Actually, we have talked about it for a while and how to use PhenoPax, for example, to do it. And Yes, we do want to implement Phenotypic to do it. And I don't know if we need any other standards in PhenoDB, but one that I can think of is we have been deciding how to use verse or not use verse. That would be something that we are also already looking at how to implement in PhenoDB, at least as a link for the variant in verse, if we can. So we have been talking about it, and yes, it should be our next steps in changing some of the things in there to implement the standards in GA4GH.
Great, thank you. So you did mention there was a decision point in terms of selecting either the Beacon or the Data Connect API. So could you speak a bit more about the considerations that you were thinking about in making that decision?
It came down to basically we could use either one of them, but the Beacon API was more structured to exchange the variants the way we wanted. And the Data Connect API had a structure that didn't make the data as private as the data sets, the databases wanted. So basically, the data was kind of shared more than what the people who had the data wanted to share by using Data Connect. It would require us to make some changes to the API to avoid that. And the working group didn't think it was worth it since we had the Beacon, and we didn't think it was worth it since we had the Beacon. Beacon served us well for what we wanted to do. At the end, we decided to go with it. But we had many discussions about how both of them could do the job and maybe how we could use Data Connect to some part of the work and Beacon to the other part of the work. We explored every possibility at the end, and it was a discussion that included both the Beacon team, the Data Connect team, and the teams that were looking into the implementation for their own databases. So we decided for the Beacon network, and if anybody else from here, from the technical groups, wants to say anything, please feel free to do so, because I'm pretty sure that you'll make a better job than me.
And as part of that discussion, were requirements fed back into those standards on how they could potentially...
Yes, as I'm saying, like every meeting had everybody from both teams and the implementers. So Miro was aware, Jonathan was aware, Jordi was aware, everybody was listening and discussing that together.
Great, sounds very collaborative.
It was, actually.
Great, because that's the goal of GA4GH. So the next question is about integrating additional data. So the question's about African genomic or phenotypic databases, but that could also be expanded. As you described the Matchmaker Exchange so far, it seemed to have a lot of US and European-based data sets, but are there groups from other parts of the world that are joining the network in the future?
So as you saw, we have RD Connect coming right next, and Hi-Fi is working on that already also. And we have been working with this database in Brazil, UAE, and India to them to have their database. They are not willing, like they are not saying we are going to connect. They just want to have their own database. But our hope is that once they have the data structured, we can actually start the conversation about how they could share the data and how they could actually connect to the networks. So that's our hope. Every country is very particular about what they can share and how they can share and what they want to share and willing to share. And we heard some of it this morning, listening to the talks about the data in Singapore, the data in Korea. So we will have to go through a process of like adapting to what different countries can do and are willing to do. And that is something that has been very important as part of our project. All the time, we want to make it as flexible as possible so everybody can work with the way they can. We don't want to say, like, you can only join if you are going to share all these things. We don't want to do that because then we are going to exclude some people from the collaboration. We really want to talk to each center and say, like, okay, what can you do? How can you do what you're allowed to do? We are probably flexible enough that we can accommodate that. So that's what we want to, how we want to do it, because I think that's the only way that you are going to actually bring everybody together.
And what's the best way for groups to connect with the ongoing work?
So if you go to the variant matching project GIF page, there is a variant level matching project email there that you can email them and that will get to us. You can also send an email directly to me or to Heidi, and we will actually give you, actually include you on the email for the meetings. We have a monthly meeting. Actually, now we have 2 monthly meetings, 2 meetings a month. Sorry. 2 months. One is more of a technical meeting that's on a Thursday at 8 a.m., and that's to accommodate time. People from everywhere in the world, so timing becomes a problem, like we heard earlier. So we have that at 8 a.m. on a Thursday, and then 2 weeks we have one that is more like of a discussion in general for everybody, and that's on a Tuesday at 1 p.m. But if you are interested to receive the notifications about these meetings and participate, and don't worry about, oh, I'm ready to to collaborate and to share. Even if you just want to listen and know what's happening there, please join us. And any comment and feedback is welcome. And we really are happy to integrate as much as we can of the comments from people who maybe are going to use as a user. I'm just going to log in and put a variant in there. That is what we need to hear from also. So that's the best way to contact us.
Great. Thank you so much, Nara. Let's thank her again. Excellent. So we'll invite Nara back up later on the stage for the panel. And now we're going to move into 3 10-minute talks. So first up is Frederik Otzen. He's head of bioinformatics at the Center for Genomic Medicine in Denmark. His research focuses on explainable deep learning for clinical bioinformatics, neoepitope prediction, clinical transcriptomics, and total genomic variation. Welcome to the stage, Frederik.
Thank you very much. Thank you. It's not this one. This one. Yes. So I will be giving a few examples of how we use the standards in the clinic. And I will go from some very low-level standards to some high-level standards. And I will tell you afterwards which one I prefer. And this is the hospital where I work. And I don't know if there's a standard for hospitals, but they all look very much like hospitals. And my office is here. I'm working late, always. We are just above the main entrance. And all the people I work with at the hospital completely misunderstood what it's all about. They don't see themselves as data producers. They actually think that the people going in here has to be treated and get back out again. And that is that is a problem we are facing. And I'm just saying this, I think it's obvious, but I think we can often get caught up in how we would like the things to be used for us as a user, or how we would like things to be structured. So this was just my little pet peeve. So just to set the scene and how it looks in that office with the light, we have around 50,000 samples going through every year, and we use for those 50,000. I will return to this number. That's why I'm saying it. We use 5,000 years of CPU every year to process these samples. 5,000 years of CPU every year, and we have rare diseases, cancers, and infectious diseases that we are sequencing. But how does it look? In the bioinformatics team, we are 20 people. I didn't do any of this, but we have the sequencing machine, and it goes through a flow like this. This is a simple flow of how it could look for just a single patient. It's much more funky when there is a cancer or trio. This is a very simple one. What we have here is what I would call a low-level standard, and it's lovely. We have a structure for the raw files, for some semi-processed file, and something that some people would consider results files. And the fact that this has been standardized makes it possible for me and my team to actually combine things. So sharing data is also an internal thing inside a pipeline. It's not just us communicating data with each other. So I just want to emphasize this, that these low-level standards are super important, because it means that I can also substitute some of these components if I find something that works better, or all this. So I really, now I already as plot spoiled, I really like these very simple standards, because it makes it easier for people. And that was also going back to my previous slide a little bit. If the standards make life easier for the ones who has to actually apply them, then they will use them. Otherwise, probably not. So these are some of my favorite standards. I think the VCF files could require a little bit of tweaking, so it's not so funky in the info field. Another standard that we'll use is the benchmarking variant, benchmarking of variant standard. And this is just an example. It's a little bit outdated, but that's okay, I think, showing how we decide on which tools to implement in our pipeline. And we, of course, want the best one, and we don't want the ones that are overfitted. So maybe there's also some work to be done on how to construct the truth sets that we are all using. Maybe we can find a way to standardize those in a way that not everyone overfits to the truth set, but just test in a blinded manner. That would be great. So standards are also a thing that makes it possible for us to get the patient in with their health insurance card. This is mine. They are yellow in Denmark. And the data go through all the hospital systems and go to the supercomputer, and we can deliver the data back to the interpreting clinics. Sometimes it's us who are doing the interpretation and make the clinical report. Sometimes it's other departments. Sometimes it's other departments around Denmark. We are very fortunate to have a common compute infrastructure in Denmark makes it possible for us to distribute the data. But these are all standards that we don't talk so much about here, but that are super important for this to be possible at all. And then I'll go to some of these a little bit higher level standards. We have a set of, this was 2,000 individuals that have been using for just noise filtering. And then we decided to look into this Beacon standard version 2, and as soon as we put the data in a shape where we could actually do that, it meant that we were already ready to share it, and we could share it in a way that we were allowed to share it. So just complying to this standard meant that the thing that we have been using for a long time could benefit other people. We are using the OMOD structure for the data, for the underlying data model, and I hope that there will be some communication, even more communication. I know that there is some communication between Phenotypic and OMOD, but there would be even more communication with this, because it also matters how we structure the data behind the scene, not only if we comply to the API front. And we will put 10 times more samples here next time. So what is in view? I think what's in view is that we will hopefully have more adaptation also to the high level standards, but maybe we'll also have more of the lower level standards that can help us all. And then I just want to emphasize this point, that using the standards is really about safety when you come from the clinic, as I do. And then I want to make two little shout-outs. One is for the International Accreditation Organization, ISO. I'm working in TC215, Subcommittee 1. They're so sexy, the names. And I also saw Lindsay Smith here, who's been working very hard on putting the Pheno package into ISO, which really matters actually, especially for EU and European health data space, where some of these standards will actually be written into some of these implications. And we're working now together on the pedigree. And I think this type of communication between the standardization organization is so important, so we don't do double work, and so we ensure that you don't follow a standard and you don't talk to anyone anyway. Then we have a little network here in the Nordics. Now you are in Scandinavian countries, the Nordic Alliance for Clinical Genomics, and we recently made a little white paper where 13 sites decided on 16 dogmas on how you would do bioinformatics in clinical practice. I'm mentioning this both because it's not easy to have 13 sites agree on anything, so I'm proud of that, but also it brings me to the next point. I think we are pretty far in what terms of packaging. We can communicate with each other via APIs. We can package stuff in files that we can share and people understand what's inside the files. But we don't have much on how the data has been produced. And we have to have that, because otherwise we have to burn all the CPU once again and again and again. It's not enough that you can have access to a safe environment and you can do everything you want. You are burning half the Amazon every time. And it also really limits the speed that we can actually get to some results. And then it's really going to be very needed, because all these federated dreams, federated fantasies, I say sometimes when I'm evil, they will really rely on us understanding what is the data that the neighbor has. And we are not getting around these data silos. I think this is pretty clear because of all the legislation. So that was all from my side. Thank you very much.
Thank you, Frederik. Our group is staying well to time, so that's amazing. Keep it up. Next, we have Wendi Bacon. She's product owner at Health Data Research, HDR UK. She's a cancer biologist who found her way into bioinformatics. Welcome to bioinformatics, Wendi. Infrastructure and now health data research, and she is keen to advocate for users and bring practical, free solutions to research challenges. She is part of the HDR UK's technology team, where they aim to streamline the health data researcher journey. Wendi, welcome to the stage.
Hello, everyone. Yes, so I'm Wendi, and I'm really excited to talk to you about how we at HDR UK are currently trying to work with GA4GH, and also some opportunities where I think we need to get to as well. So I thought I'd introduce us because we're a little bit of a weird one. We're neither academic nor we're industry. We're somewhere in the middle. So our general vision is that we want every clinical decision to be impacted by health data research, which sounds kind of grandiose, except for this morning has been very uplifting. I feel a lot of faith after seeing some of the talks today that this is actually achievable. We have this idea of the data lifecycle, which we've seen numerous times, and how we're trying to make it easier to do health data research, from finding the data to accessing it, all the way up to actually implementing it and improving our healthcare. And we were really lucky a couple of weeks ago. We had Sasha actually come from GA4GH and come give a talk to the entire institute, or to our senior leadership team, on how GA4GH is approaching these problems on a global scale. And it was a very similar image, actually, of this data lifecycle, so I feel like we're onto a winner here. So we also have slightly similar in how we set ourselves up. So we have the British Heart Foundation Data Science Centre, and these are the guys who've done some of the most incredible studies across the entire UK, the entire population, looking particularly around COVID and vaccination and heart disease. So they're proving that it can be done. It's just really hard to do it. We also have these research driver programs. So this is where, again, we're working with institutes across the entire UK to drive research forward, to drive technology forward in the health data space. We have the UK Health Data Research Alliance, where we try and get all of the cats together and herd them in the same direction. We get the heads of data custodians across the UK, people in these high-level senior positions, to actually come to the table and try and agree on what their standards would be, on what their approach would be. We also have programs in usable data, we do capacity building, we have regional networks, we have hubs. We've tried to cut in every way possible across expertise, location, interest across the UK to try and bring people together. Finally, on the technology side, which is more where I sit, we have the data and analytics research environment, so DARE UK, and so they're beyond health data. There are all sorts of different types of data in secure environments. And then we have the technology ecosystem, so the tech team where I sit, and then our federated analytics, or indeed federated fantasies, maybe, a group that, again, works across the UK. So even if you've forgotten everything I've just said, the important keynote here, or the key here, is that HDR UK is a non-for-profit charity. We're working with government, we're working with charities, we're working with research councils to try and make research easier to do. We want to streamline the researcher journey. We want to prevent multiple people all trying to solve the problem in different ways. We want to create one solution that hopefully everyone uses so they can go and do useful research rather than reinvent the wheel over and over again. And a little bit about us from the technology side is that we are very passionate about being open science, open source, open APIs, open science. We don't lock people in if they want to use our tech. I have a running joke that you may or may not find funny, that I really enjoy selling free software. So the other thing that I really like about our team is that we're a mix of academics and industry folks. So we both have this really cool emphasis on scalable, secure, stable software, but also the academic push to sort of push the envelope, or how can researchers actually use this. We are community-led. I've just shown you a whole slide about how we work with people, and we have extremely passionate user researchers on my team. I get to supervise quite a few of them, and they are extremely passionate user researchers to try and make everything we make actually usable. And then the final thing is we're not too precious. If people want to use our stuff but put their own logos on it, that is fine by us. We've solved our issue of preventing work duplication and making things easier. You use all the logos you like. So all great technology solves problems, right? So let's look at a couple of pieces of our tech and the problems we're trying to solve. So health data research is powerful. I don't think I need to justify that statement, but a part of me was trained very early on that you always should. So anyway, I found some blog posts from our HDR UK news. If anyone is ever having a bad day and you need a bit of an uplift, because we tend to work on where the problems are, our communications team gets to work on where things have gone well. And so they have these lovely blog posts that they put out about successful research ventures. So if you're ever having a bad day, look at the HDR UK news postings. Right, so we know health data research is powerful. We know there's loads of health data sets. And we in particular focus on those in trusted research environments. We're talking secure, sensitive data that cannot get shared easily. So we've already started there with doing a lot of work about how we define these trusted research environments, standards for those trusted research environments. So we have SATRE, the principles, trusted research environments. There will be links, all of this stuff at the end as well. And then the problem that we're solving with this piece of software is it's hard to find these data sets. Even if we've gotten all these TREs to work together, these trusted research environments to come up with a standard and how they host the data, for the researchers then to actually find that data can be quite challenging. So this is where our Health Data Research Gateway comes in. So how this works is we have our lovely data custodians over here. They will have cool data sets. They upload metadata onto the health data portal, onto the gateway portal, and then that means researchers can find it. It's obviously a little more complex than that. We get a whole bunch of information about those data sets. You get publications, scripts, software, what custodian network is this a part of? And what's really cool about this is we've done a huge amount of engagement around this to get as many data sets as possible on this. We are talking to trusted research environments on a daily basis, particularly our National Health Service, to get data sets onto the site so people can find them. Another thing that we've put, once researchers have actually found a data set, how they can most easily actually gain access to it. So we have a data access module built around community standards agreed with our UK Data Research Alliance. And then a place where I think we can go, and a place I think we should go, is the data use ontology here and how we're actually describing this. This could be a place that we could integrate better with GA4GH. Another piece of software that I have is, again, trying to solve a problem. So we know that there are loads of health data sets that can be used for research. But we also know that patient data must remain non-identifiable, and people have different words for describing that, so we're just going to go with this one for now, all right? Welcome to my TED Talk. Right. But finally, we also know that it's hard from a researcher perspective. If you can't actually look into the data set, it's really hard to know if it will actually give you the information that you need. So this is where stuff like the OMOP Common Data Model come in, where you have a standardized ontology for describing what's in a data set. And for those wonderful data custodians that have OMOP'd their data, we have a cohort discovery tool. And the way that this works is a researcher can ask a question. How many individuals in the UK have a diagnosis of Alzheimer's disease and are over 65, or have asthma and are female, 25 to 35? And they can actually look across all of the data sets in our cohort discovery tool and get numerical output on the number of individuals that would fit that cohort. It goes through a very cool pseudonymization process, and then of course, because it's incredibly important that no one can find a single individual, the data gets kind of massaged a little bit again, so you get these summary answers at the end to try and again maintain people's privacy, but give researchers the information that they need. A cool place we're already going with this is the Federated Analytics team have built the Bunny, which can exist in a trusted research environment, and wonderful data custodians only have to install this one piece of software, which can then actually integrate with beacons, with our cohort discovery tool, bringing together both health data and genomics data in this federated search, which is pretty darn cool. We have over 1 billion records from Scotland already in our cohort discovery tool. It's constantly growing. It's a very exciting time in this space. And then the final bit of software I'll tell you about is around our big thing on data access, which seems to be quite an issue in this space. So we know sensitive data research is powerful, and we know that we need to control that access. We are massive proponents of the 5 safes. Mostly because I meet with Felix Ritchie quite regularly, so we definitely have to be proponents of the 5 safes. And with this, we've created a number of outputs around standards, around who should be accessing what and how, around the actual outputs and checking the outputs to make sure that everything has remained safe. So this is the Alliance outputs, where they have convened all of this community together to try and agree on what we could look at here. And so when we're specifically thinking about the safe people aspect of the 5 safes, what is it you're actually looking for in an individual to determine that they are safe and a bona fide individual to access your data? And so this is where we've done, again, a lot of community effort to try and bring together the different standards and considerations. We've published guidance for how you can assess safe people in organizations, and actually there is a wonderful section of the DACRA's toolkit that actually talks about looking at the individual as well, and I can confirm our software integrator is aligned with that, so that's quite good. So I'll tell you a little bit about the Safe People Registry. So the way this works is you'll have a user who is your researcher, and they will come along and they'll create a profile. It's a bit like LinkedIn, but for safety, right? And so we have already integrated this with Life Science RI, so there's a lot of potential for how we can work with GA4GH. They create their profile, and then the organization that educates or employs them will come along and they'll also create a profile, and they will affiliate that user. They will say, yes, we are legally accountable for that user's activities. The data custodian can then actually go and validate that user and organization with the appropriate criteria to determine whether or not they're safe. And then this is, again, a direction I think we could go with this piece of software is integrating better with passports, the GA4GH passports, to actually go from decision to access. So in sum, how does our software fit together? We start at data discovery. People can find data using our gateway. They can actually find numerical summary of data using our cohort discovery tool. They can use the data access module within the gateway to go from finding to accessing. Custodians can use the Safe People Registry to actually monitor who has access to their data and whether they should. And then I didn't even talk about it today, but I know that there's a section on this week on federated fun. So the federated analytics team and the work that they're doing, which is already integrating with the task execution service. And then finally, a little bonus, because transparency was a big topic today, is that the wonderful data custodians, if they put data onto our gateway, will automatically get a data use register out that conforms with community standards on data use transparency. So, places we can go, we need to make friends with Beacon, passports, data use ontology, and anything else you tell me this week. So, a big thank you. This is my first GA4GH. I'd really love to talk to all of you. People have been really nice so far, and teach me your knowledge and give me your ideas on how we can work better together. Thank you.
Thank you so much, Wendi. So we have one more talk before we head into the panel. So that is with Marko Malenic. So he's a research software engineer at the University of Melbourne, their Collaborative Center for Genomic Cancer Medicine. His interests are in building open, community-driven software where real-world implementations of GA4GH standards can interoperate for effective genomic data access. Welcome to the stage.
Hand mic, please.
Yeah, that's fine. We can do that. All right. Hello. Okay, that's working. That's working. Great. I'll try again. So my name is Marko, and today I'm going to talk about real-world htsget for data sharing. Yep. And so a bit about me. I'm a software engineer at the Collaborative Center for Genomic Cancer Medicine in Melbourne, Australia. I work in a team, in Oliver Hoffman's team, on a team where data is sequenced through a sequencer, and then that gets used downstream to inform cancer treatment and diagnosis. And in case anyone's noticed, that's not actually me, so that's my colleague Roman. He's not here today. He has been really, really great and really quite key in making this project successful. So, and his work has been joint work with me to make this happen. So today, I'm going to share a bit about the context of the problems that we have at CCGCM. I'll do an intro on htsget and htsget-RS, and talk a bit about challenges in future work, and also a discussion on standards and implementations in general. So the question that I want to share, or want to sort of answer as I progress this presentation, is how do we share only the genomic data that users need to see? And as I progress, hopefully I'll be able to answer that. So a bit of context. We have a curation team that's analyzing files like BAMs and VCFs that come out of the sequencer. They run through the pipelines and the workflows, and they get output, and then they get analyzed, and that informs the cancer treatment diagnosis. And one kind of analysis that they do is a germline review of cancer patients based on a familial cancer gene list. In this list, the intent is that they should only be able to see the genes that are allowed based on that list. So the solution that we had initially to do that is we statically strip data from BAMs to solve that. And the disadvantage of this is that that means that you have to store the BAM files twice instead of just once, and it also means that you have to regenerate if it ever changes, if the list changes. So instead, we'd like to use htsget to dynamically send only the data that's required. So what is htsget? It's a GA4GH standard. It's a protocol that defines how to share and transfer reads and variance data, so data from BAMs and VCFs, and it's split into two parts. Initially, what happens is the user is going to request data from the server, and then they'll get returned a set of URL tickets, and then the URL tickets are going to be re-requested by the client and then concatenated, and that is the final output of that request. So I think this is pretty cool because I think it makes it quite flexible actually in what can be requested. So one thing that you can do with this is that you can be a user who only requests, say, a particular gene or a particular region, and it'll only return that set of data. And another advantage is that it allows users to quite dynamically resolve the data that they're requesting, and also authorize them into particular sets. That's going to form the part of the demo today. So what htsget-rs is it's an implementation of the server that we've done at CCGCM, alongside with Roman, and that has this authorization logic that allows a user who logs in, oops, that's the laser, okay. Allows a user to log in through a UI portal, which then allows the request to go up to the htsget server, and then the htsget server will authorize that using an authorization service, and the authorization service allows that user to see the data that they're authorized to view. So as an example, here is a sample that's gone through, and this is in the UI portal, and for example, a user will be interested in a particular file. This is an overview of the sample and the case, and there's some reports. They might search up the files that they're looking at. So in this case, this is a germline BAM file, and they'll be able to load that into IGV. We have both IGV.js and IGV desktop. In this case, I'll just show the browser built-in version. So this is a publicly available sample that's been run through the sequencer. And in the case of an admin user, the user will be able to see all data that's available in that file. Alternatively, if the user is only authorized to view some of the regions, they'll only be able to view some of it. So in the backend, the request will be negotiated, and the user will have data that's cut off after a certain area based on their authorization. So that, I think, helps answer the question of how do we share only the genomic data that users need to see. So by using htsget and taking into account who is requesting the data, what the context of the request is, and what the underlying consent of the sample is, we can achieve this level of nuance using htsget as the object store. As we were implementing this, we had some challenges, I think, as is often the case when writing software. So I think one of them is that authorization is quite hard. It's not clear always the best way to approach something like this. I think when we were writing the authorizer logic, we tried to keep it as generalizable as possible. And to do this, we had this split between the two services so that there's a separation of concerns between the authorization service and the object store. And I think that that split allows us to make it quite flexible and general so that other people can also use it. The intent is that there could be any authorization service backend here that's communicating with the htsget server. A bit about future work. I think there's a lot of strong possibilities in terms of integrating this with other GA4GH standards. So one of them is GA4GH interoperability, which is already supported by htsget RS. And another good contender there is GA4GH passports. So instead of using a JWT token as a plain sort of request, there can be a passport there that authorizes the user, and that gives even more flexibility to how they should be authorized. And also there's the possibility of DRS integration. As a discussion around standards in general, I think there's this overlap between when you're implementing something and then there's a standard as well, like a spec. It will sometimes, it won't be clear what you should do as the implementer versus what the spec says. And I think in this case, we potentially broke the spec in doing this because the way that it's phrased is that you should return only the more or equal to the amount of data that's requested, but in this case, sometimes we return less data based on the user's authorization. I think in this case, there should be clarity in terms of there's a good opportunity to update the spec here and also clarify how specs interact with each other and what happens if a standard is not well used. I don't have the answer to these questions necessarily. I think they're open questions. Join the discussion if you like. There's regular meetings now. There's one coming up in November for htsget. And before I finish, I'd also like to acknowledge the funders, Australian Biocommons and Australian Genomics, and also thanks to Jim Robinson for his work on IGV.js and IGV. He's been very helpful in implementing features that we've had for this. And also thanks a lot to my team. They've been very, very helpful in answering any questions I've had. I'm a programmer, so I'm not a bioinformatician. I don't always know the answer to some specific questions, and I ask them, and then they help out a lot. And before I leave, that is a stripped-down demo of this code. So if you look at that, you can load up this software and the architecture, including htsget RS, locally using a Docker Compose and play around with it. Thank you.
You could stay on the stage. Great, so now we'll move into the panel Q&A. So Nara, Wendi, Frederik, please come back up to the stage and grab a seat. As a reminder, everyone can submit their questions on the Slido with the GA4GH hashtag. Either if you have a question for a specific person, please put their name, or if it's a general question as well. And then due to some scheduling changes, we actually have a good 27 minutes, I think, for questions. So please add your questions. I would just say it was great to see so many, both technical standards, but also some of the policy frameworks highlighted in these 4 talks. Really demonstrating how we're actually implementing these standards in practice. So we will start with, I guess you guys will have to crane your necks to read if you want, a question for Frederik about phenopackets. So to what extent are you using phenopackets in the project you described? Also, as a researcher, is it possible to obtain clinical data as a phenopacket? And have there been any hurdles using the standard for your project?
Those were many questions.
To what extent?
I can rather say what we are doing, and maybe that solves some of it.
Go for it.
So because we start with the OMOD model, and I should remember the names, but I don't, there's been some work ongoing to translate from OMOD to phenopackets, and that actually helps us to do it immediately. And I have to say, if that work hadn't been done, I think we'd be further away than we are. So that's that was our simple take on it.
Great. Any hurdles on using the standard?
Not since we have this conversion tool, but whether we are not going to fulfill every single field, but we are taking as much as we can, as early as we can. I think that's the approach.
Excellent. The next question, I think, is for everyone, so anyone has a chance to answer if they would like. So in the talks earlier this morning, we heard about the European Health Data Space, about some of the standards they're focusing on, including OMOP, LOINC, and FHIR. So now we're hearing about getting ISO to recognize phenopackets. So as a standards community, how could or should GA4GH try to coordinate efforts for impact? And I forget who mentioned ISO. Was it you as well, Frederik?
It was me also.
Yeah, but anyone can also take it. Maybe start, Frederik.
Okay, I can start since I threw it in there. But I think exactly what's already happening, which is we have cross-coordination. And yeah, and Lindsay, I saw you here, is participating in the meetings, and we are having these big dashboards on which of the standards are in development, which ones align, which one are filling which gaps, and so on. I think it's very nice, but it requires probably more hands than we have available to do it perfectly.
And how could someone get involved in those efforts if they had some ideas?
You will have a standardization organization in your country, and you should know them if you don't already, and go talk to them, and they are usually super happy to get involvement, and I know they are, because it's hard to get to the right people, and we really need some people also who knows to write a line of code, or medical doctors or others. Yeah, the experts are hard to come by. We manage, but the more the merrier. Yeah.
Great. Anyone else want to comment on standards coordination efforts? Okay. Phenopackets was accepted as an ISO standard in 2022. It's done. Hooray.
The Phenopackets, yes. The pedigree, it's ongoing.
So maybe it's a communications challenge or an advertising
Peter has
challenge.
something to say.
Okay.
But I think Peter wants to say something.
Yeah, give him a chance.
There is you got it right, ISO TC 215 Genomic Subcommittee 1 is meeting in Toronto in a couple of weeks for all of those conversations. So.
Okay, that's probably the fastest solution to a challenge. So well done, team. Next up, a question for Wendi. Are there additional needs or challenges at HDR UK that could be addressed by passports and Duo? And to what extent do you see both standards being most useful?
Cool. Yeah, so I would say the easier answer there is Duo, which seems just a straight up win. You know, we have metadata about all of our data sets on the gateway and how we're actually translating that. You know, obviously, there's always historical context to why different pieces of metadata were chosen and how they were chosen and how we sort of, you know, onboarded a community and got the community going in that direction. Nevertheless, it just seems like an instant win that you can just slightly tweak your ontology and then suddenly it's more findable. So that just feels, it's already on our roadmap, we're going in that direction. In terms of the passports, also to be fair, on a roadmap, going in that direction, but I think that one has an even bigger win for me personally because I work on the Safe People Registry, so that's my baby. And that would be the connection we would have between decision and actual access. So one of the things that we've noticed within our secure research environment, within our TRE community, our trusted research environment community, is everyone's very keen on keeping everything insular. There's a lot of fear, there's very understandably, you know, people want to stay secure, they want to have control of everything. And so we actually offered the feature of connecting single sign-on with, as soon as they would click validate on the Safe People Registry, that person would gain access via the single sign-on. And actually, most custodians have said they didn't want that because they wanted to be able to control the decision. So for us, the passports is almost like an interesting use case where the other side of the custodians who do want to say, actually, we do want to connect decision to access, please let us do that. That would be the direction we would get to go and actually see this implemented in real time for the custodians who have chosen passports to be how you can gain access to their TRE. So yes. I think I answered that. Happy to discuss further.
Thank you, Wendi. I'm going to pull moderator's privilege and ask a question. So as co-chair of the GA4GH Implementation Forum, I'm always interested to hear what some of the effective ways to collaborate to either build or implement standards are. So maybe starting with Marko, and we'll go down the row. I'm wondering, in your experience, what has been an aspect of implementing either htsget or something else that's been super useful? Is it through meetings? Is it through some technical aspects? So what's been most useful to help you in your project to implement a standard?
Yeah, that's a great question, I think. I think for us, we implemented, we're implementers of the standards, so we're not really the standard kind of writers that much, but there is a bit of an overlap there, I think, as well. Like if you're the implementer and you are discussing this in meetings with other people, that then helps you also discover how you should implement something and also helps the standard develop and progress as well through time. So I think a useful part of this, I think, is to have those meetings. I think it's good to have the regular meetings for the standards and then discuss and progress how the implementations and the standards should interact together.
Great, thank you.
Can I say something about it? I do think that we need meetings that are specific.
Your microphone works.
I thought I needed that. I don't. Too many mics. I think it's important, the meeting for the implementation itself. We have had that throughout every project that we have engaged, and having the technical people meeting among themselves and actually doing it and discussing what was done between one meeting and the other and exchanging mails among themselves is very important. And then having the presence of someone who understands the standards in this meeting is also very important. So many times we had to pull Jordi in or Miro in or Jonathan in the meeting because we needed a better understanding of the standard to actually implement them and get the things working. So having these meetings specifically for the implementation that you're planning and having the support of the people who wrote the standards is very important.
Thank you. Wendi?
I approach this a slightly different way, but I'm also a biologist, right? So I'm not the technical person making the stuff. I work with the brilliant technical people who make the stuff. And is sneakery a term?
Sure.
So the example I'll give here on how we're always talking about software to help people, but actually software also involves people and how they make decisions. So my key example here is we built this Safe People Registry, and it had stuff like CV or ORCID or their previous roles or have they done X, Y, or Z training. And what was fascinating was you had a wide array of how data custodians wanted to manage people. Some people wanted to know all of this information and 10 times more, and some people literally just wanted an email address. And they were guarding the same level of sensitive data. And so this is why standards are necessary, right? This is why we need to pull the community together. But what was fascinating was once we made this interface that had all this information, we were going and talking with data custodians, as the custodians who are on this end of the spectrum, where all they wanted was an email address, were like, oh wow, other people are looking at CVs. Oh, maybe we should put that in our process. Oh, other people are looking at this training. Maybe we should put that in our process. And it almost felt like a very cool, subtle way that just building the interface that surfaces its information or making it as usable or as clear or as easy as possible kind of tricked people into doing a better job. So yeah, I quite like the idea of the more intuitive and usable you can make something, the more likely people are going to implement those standards.
So trickery is successful.
Yeah, sneakery.
Sneakery. Frederik, any thoughts on some successful ways to implement standards?
The actual implementation or development?
Or either, or both.
I think my point is always that if it makes life easier for people to use it, then they will use it. And I think this should be the starting point, rather than we would like to have things ending out in this way.
Yep.
We can get there, but the smaller standards or lower level standards are easier to come about with.
Agreed.
Sometimes what is easier for one is not as easy for the other one. And we have found that also. Like for implementing one of our tools, we have been working with many different places. One place was able to implement that in a week. So we were like, okay, we did a good job on making it easy. This group implemented in 1 week. This other group implemented in 2 weeks. This other group is taking 6 months to implement it. So sometimes it's also have this notion of like what it's easy for us in a place that has every resource that is possible out there is not as easy to someone that's in a place where the resources are more limited. And we have to adapt to it also. Just have that idea that what's easy for us is not as always as easy for someone else.
Yeah, I think that's an important part of the implementation life cycle, is getting that feedback on where people are challenging and be open to changing up the documentation, the specification, to enable implementation. Okay, I wanted to ask the second one. Does anyone want to comment on how GA4GH standards can translate into improved patient outcomes, or maybe some examples of how this has happened? Anyone can take it.
I thought I showed that.
Any other examples?
Didn't I? Then I didn't do a good job.
Any other examples? From Denmark.
Are they healthier when they walk out the door? Are they more happy? No, but I mean, as I tried to say, just the fact that we can communicate between the blocks, it means that we can do our job better. And just the fact that we can test and validate stuff in a structured manner, we can talk to each other about it, means that we will have better performance in our pipelines and all these things. And we can change one component from a commercial vendor, and we can take open source code, and we can switch and swap. This really means that the product gets better all the way. So now I'm talking a little bit from the engineer perspective because I'm an engineer, but it ends out being better for the patients.
Great. Any other examples anyone wants to mention? No.
The variant of uncertain significance is a big thing. You know, like as a clinician, I don't know how many clinicians are in here, but like it's a big problem right now for us in clinic to receive a report that has a variant of uncertain significance. And you get almost every day in clinic at least 2 of them, right? And you don't know what to do, and it's a big thing. Maybe one of you is a patient, and you go to the physician with a variant of uncertain significance, and the physician is like, well, now I don't know if I order this MRI of your brain or not, because it could be that you may have a cancer, increased risk for cancer, or maybe that you don't. So, like, this really affects the physician decision, the life of the patient, and the cost of healthcare for everybody. So everything that we can do to share the data, to make sharing the data easier, to improve variant classification. Of course, we want gene discovery also, but variant classification, it's a big problem right now, that anything we can do to help with it, it's going to impact a lot of people. From patient to whoever is financing the healthcare of that patient to the physicians who are managing that patient. Everybody's going to be benefited from it.
All right, the next question, I don't know who wants to take this. Why aren't we all using FHIR to query clinical data?
Don't worry, we will, because we have to. It's already written in the law, so that's the...
stay tuned.
Yes, we are not allowed not to, so easy peasy.
And I think in the US also, FHIR, I think NIH is using FHIR, and I think FHIR is going, I think EPIC, I don't know, Catherine, EPIC uses FHIR, right? And EPIC is used in most of the large centers in US now as a EHR. So I think FHIR is, in US at least, making, if it already didn't do its way in, data sharing clinical side.
Yeah, I think if we can support the interoperability component, then by default, anyone could use FHIR if they're using an interoperable standard. Okay, the next question, and again, this is for all speakers. How involved were you in developing the standards that you used versus being able to use them sort of off the shelf? So maybe we'll start at the end with Marko and work our way up.
Yeah, that's also a really good question. I think, like I said before, I'm pretty involved in implementing the standard, but not as involved, actually. What was the question? It was...
being able to use it off the shelf.
Oh, off the shelf. Hold on. What does off the shelf mean in this context? So
you just took it and used it. You didn't create it.
Like you were able to adopt it without
Yeah,
being
you just
involved
got
in,
it ready
in
and
creating
implemented it. You didn't participate on the development
Oh,
of
I see
it.
what you mean. Yeah. Okay. Yeah. I think for me, yeah, we're definitely like implementing the thing. There's not really, in this case, an off-the-shelf part to it. I think for off-the-shelf code, that is slightly different. And I think with the standards, I think there's always going to be a bit of a component where there's going to be a set of people who are maybe implementing things, and then there'll be other people who are using that off the shelf in this case, or maybe trying to not being as involved in the actual implementation. I think that's good. And I think that's kind of like the intent of this sort of implementation and standard thing, because if there's a standard that is written and then there's an implementation for that or multiple implementations, then other users can choose or use that how they'd like as well. So, yeah.
Thank you. Wendi?
I started in April, so I have not been instrumental in making a standard, no. Our team has, HDR UK do a lot about making standards, and so I was very lucky to just get to pick up what they had gotten all the community to agree for and then just make the interface, make that as intuitive as possible, so none of the future users of the interface have to know that there was a standard. So, yes.
Are any of the HDR UK tech team involved in developing any of the standards directly, or are they more of the adopters?
Well, for the UK standards around TREs, around the 5 safes, around data access agreements within the UK government framework, absolutely, they're coordinating, they're implementing, they are coming up with them, they're pulling their hair out trying to get people to agree, they're in the trenches, so to speak. And then it's something that I'm here to try and make us do better, is how we can engage more globally with that once we try and get the UK to move as one.
Good luck. Nara?
So I'm not a bioinformatician, so I don't really put my hands on the technical side, but as a user, I have been part of the development of the API that was the first API for the matchmaker exchange. And then when we are developing the API for the variant level matching project, I was part of this process, and that ended up becoming the Data Connect API. Again, I was part of the process from the beginning as a user, not as a technical person developing it. But I do think that this is very important. I do think if we only have the technical people developing an API, it becomes a little disconnected with the needs of the user, and it may end up not being adopted because it's not serving the user the way it should. So I think as part of the process, as much as we can, to include that user that maybe for you, it's a naive, stupid person like me that doesn't understand anything of the technical part. It's important. And I was not part of developing Beacon. While Beacon was being developed, I was on the Data Connect side of things and the Matchmaker Exchange API side of things. But implementing Beacon has been very easy. We didn't have major problems, and having, like I said, the people who understand Beacon helping us is also very important. Georgie has been great on helping us every time we needed.
Great. Frederik?
I simply hired someone who'd been working developing the Beacon standard already, so I was cheating.
So it sounds like for Beacon.
I was not cheating. I was very fortunate, and that of course helped a lot. Yeah, and we have been in communication.
Excellent. Okay, the next question is for Wendi. So what mix of push and pull do you see in working with the adopters of HDR UK tools and standards? How do you balance the, if we build it, they will come, and nobody comes, with our users only ask for faster horses?
So I would like to have a coffee with you, David, because this is the best question ever and uses all of my favorite quotes. I love a baseball film. Great question. So this is where my background is actually a bit in pseudo-bioinformatics land, where we were making an interface for people like me who are non-technical to be able to do bioinformatics. And fundamentally, it was around community building and open source and open development. And I think this is direction you have to go, is you have to understand, the software changes people change the software, and the more people you get involved in that process, the better it is. So we have some fantastic user researchers that span from industry industry to academia. And we work together because we can communicate with all these different types of people and actually bring them along in the development process. So we did something really cool recently, which was usability testing, where we just had the thing that you never have time for, right, when you're building something, as we sat and watched people use our software for just hours. We brought in different people to see how they were doing. And what was really cool about this is, one, we identified hundreds of things that we wanted to improve and change about this one piece of software. And all of those people signed up to be part of our beta testing. All of those people signed up to talk with us about our roadmap. All of those people then invited other people to come talk to us about our roadmap. So I think there's so much there about getting people in the trenches with you side by side working together that creates this loyalty, that creates this community spirit of people wanting to move forward. They got to show up and be important in a meeting one-on-one in that moment and have their voice be heard. And how often do we come to things and scream to the rooftops and not be heard? So I think that's a key part of this, as both they're making the standards and conforming to the standards as we all do it together.
Great.
Could I just add to that as well?
Yeah, sure.
I think that's really, really important as well, like when you consider the usability part of it, I think, and going off of before mentioning when there's just people implementing something or writing something without actual user sort of integration or testing and all that, I think it becomes a little bit detached. So that kind of feedback is very, very useful to have, I think, for software in general. So, yeah.
Great. Yes, we love collaboration. Okay, the next question, and we have a few minutes left. So I think this one's for Nara. It's about the VLM network, and it was unable to use the passport standard currently due to challenges with a central authorization registry, which made the use of passports a less desirable option. So is there a solution around this?
In my understanding, passports. Oh, okay. I thought you were saying passwords. I was like,
sorry, passports.
Yeah, so we have discussed passports for a while, and actually the paper that we described, we were doing the variant level matching project, we described using passport because we planned to use passport. But then when we got to the point where we were discussing the implementation, passport sounded much more than what we needed. It would bring another level of implementation, more time, more effort than what we really needed, because we are not exchanging, we're exchanging a variant name, a variant coordinate, and we didn't feel we needed that much like protection or security around that type of data. So for now, we are using Auth0 because that gave us the protection that we needed and the easy implementation that we're looking for without every center having to do much more extra work. We have not decided that we are not going to use passport, and we may use passport in the future. But for now, what made our work more possible was Auth0 as an option. So I think we had a lot of discussion about what type of data we were exchanging now, what we needed for that, and we came down to Auth0 is going to be what we need. It's already an improvement from what we had before. We exchanged tokens for the matchmaker exchange. We have never had a problem with tokens, but we didn't feel like it was the level of security that we needed for the variant level project. So I do think that maybe in the future, as we talk more about the exchange of phenotypes, and depending on the level of phenotypes that we are changing, we may need to implement passport. I know that some of the people who are looking to join in the network have already implemented passport, so we may get to the point where we are going to use passport, but for now, we decided that Auth0 was what we wanted for that stage of the project.
Great. All right, it was wonderful to hear on your talks today and the follow-up questions about both successes and ongoing work to implement GA4GH standards in the real world. So let's thank our speakers again. Good job. And now I think we're headed to a fika, a break.